Oh, just as I did it, someone came in. There we go. Well, good morning, everyone. This is a very, very short week for you, and this is the only class this week. Right. So what I'm going to do today is finish off chapter 8.5. And next week, we have a full week, and that will be to do the 2 sections from chapter 9. So we're well on schedule, right? So that's good. So keep that thought. Remember to make sure that you keep your homework up to date. I know it's not due until Sunday, the 6th of December, and that is a long time down the road, but it isn't really. It'll shoot up on you like nobody's business. So if you let it get ahead of you, you're just not going to have a very nice weekend on the December weekend, especially the fact that your test is virtually after that. So you got a lot to keep on your plate. Okay, well, let's get to, oh, I shouldn't say let's get started. Every time I do it, someone appears. Right. So let's get started. Let's get it over. So the last thing is to do is we're testing then for the difference in two means. We looked at testing between two proportions, and I did one of them by hand just to show you what it's like. I could do this one by hand. I have no intention of doing this. It would literally take us 20 to 25 minutes to do one question by hand. It's just a whole lot of number crunching. Now, you can certainly look up the textbook and you can go through the process by hand, but we're basically going to let Salt do most of the heavy lifting again. There is a lot of same old, same old. Hypothesis test at the start with significance level, and at the end, there's enough evidence to reject H, not insignificant, and what does it mean in English? So the beginning and the end kind of look the same as we did in proportions. So I'm going to start with this made up story. Let's suppose we wanted to have an idea about how profitable two of the major parts of American finance, business work. So we've got utility companies, right? Electricity companies, gas companies, things like that. And then another family, consumer goods. So the people who make cornflakes and bleach and things that you'd use in your house and so on. And what we're going to do here is that population one is going to be all the companies that are essentially utility companies. Population two are all the companies that are consumer goods companies. The mean mu one would be the average profit that a company from this group makes, and mu two is the average profit that a company from this group makes. And we're interested in how these two groups interact. We're essentially interested in, does this company make more or less than that, or are they different in some way? So it's the usual left, right, or not equal to. So that's very common. In this one, we'll call it sample one. We got 50 companies at random, and we found out that the average that they made was 120 million, and that the standard deviation was 50. And over here in the second one, we did 75 companies. We found out that theirs was 100 million on average, and standard deviation here was 10. Now, unconnected with hypothesis test, there's a couple of interesting things here. The first one is, isn't the average for the utilities companies, they make more money than the consumer companies in general? More profit. And secondly, the variation, right? The standard deviation is quite exceptionally different. For a utility company then, it's quite obvious that couldn't you have a big difference in how, there might be some companies making 200 million, 400 million, other companies could be losing 50 million. Whereas over here, isn't it kind of, okay, they won't make a lot, but they might make 110, 120, they might only make 80 or 90. So if you were in the stock exchange and you were buying stocks in a company, there would be two different. One of the things you would be looking at is the profit of the company, right? So if you wanted to play safe, wouldn't you pick a consumer good company? Because you know you might not make as much money on the stocks, but wouldn't you be pretty safe? Because even in a recession, don't people still buy cornflakes? On the other hand, you might make more money on utilities, but you might lose more money in utilities, right? I mean, if the country takes a downturn, you know, things like oil, the price goes down, the companies make less money. People tend to dial back on other things like don't use all, you know, switch all the lights off and don't use the same amount of electricity. You know, you try to reduce your costs. So this is my little story then. So here's the question we're being asked to test, the hypothesis test. Is there enough evidence to prove that the average property from company one is greater than the average from company two? So let's look at how that gets set up then. First thing we're going to do is the hypothesis test. Technically, two of them. The null hypothesis is that they're both equal to each other. And that's always going to be the case. Is it not P1 equals P2 from last week? The same thing, right? It's always equal. And then the alternate depends on the story. In this story, is there enough evidence to prove that the first one is greater than the second? The first one is greater than the second. Now, I'm going to put down the other two situations that can happen. Company one makes more than company two, right? Company one makes less money than company two. They make a different amount. We're not quite sure what the difference is, but they're not the same. In salt, don't we have to rearrange this in a slightly artificial way? So what does that mean? I'll use red. This is the same thing as saying mu1 take away mu2 is greater than 0. This is the same thing as mu1 take away mu2 is less than 0. And this is mu1 take away mu2 is not equal to 0. Do you see that these red guys are mathematically the same thing as the blue ones? The reason why we need to keep this in mind is that when we do, you know, the little box thing and the number, won't that be a 0? But this will be a less than. Oops, this will be a more than. That's what I meant to say. And when we do this one in salt, won't that be a 0? And then we will do a less than. And then when this possibility happens, won't we do, I can't remember, did they just give you a little not equal sign or something? From what I recollect. That and maybe some words. So far, so good. So we set that up. In the homework, you will just pick whichever one of these three is the right one. That's pretty typical. And now we are ready to plug this data here into salt so that we can find a number of things. We're going to find that guy. We're going to get a t-score, which is called the test statistic. I wish they would just call it what it is so it'd be easier to find. And we're going to find a p-value. These three things salt's going to get us. So we're gonna go here and here. Okay, so right now you're all looking, I hope, at just a random question, but I just need the salt one, right? So I'm hitting salt. Brittany just came. So what you got here? Well, maybe make it just a little bit bigger if I can get away with that. There, maybe too much. There. Remember, this is comparing two different things. So when we go in here, it's a two sample T. Remember, it was a two proportion when it was a P1, P2 story. It's a 2T now, two sample T. Now, sample one had a mean of 50. No, it didn't. Had a lot of done question. Had a mean of 120. Type the right number in. It had a standard deviation of 50. And the sample size was 50. So if you could see my piece of paper right now, that's where these numbers are coming from. And then I go down to the second one, which was the consumer goods. And they had 100. And the sample stem, that was 10. And this fella here was 75. And we're doing a hypothesis test. The difference, just leave that as 0. And we wanted to prove that it was greater than, didn't we? So it's all set up. So when I hit generate results, we should have all the numbers we want and some numbers we don't want, but that's okay. The difference is 20. So x1 bar take away x2 bar, that's what the difference is 20. Which I could have done just using the data I had. The T statistic is 2.79 to 2 decimal places. And the p-value was 0.00, round it off 4. So that's us got all the stuff. Difference, t-score, p-value, right? All done by Salt, pretty quick. And I forgot something in my story. Shouldn't you also get in the question a significance level? And I'm going to assume that it's 0, 1, right? So we've done the null alternate hypothesis. We've collected this data. All I need to do now is the test. And it's the same for every one that we've done. Every hypothesis test, no matter what the story was like, wasn't the test always, is the p-value less than alpha? Every time. Now, our p-value is 0.004, and we're testing, is it less than 0.01? And the answer is yes. So what you're going to be asked to do, should I get this thing sorted out, is that they're going to have a guy called E and then a guy called F, or at least it's the last two letters, whatever it is. And when the answer is yes, you will choose the option that looks like this. At the alpha equals 0.01, because that's what we were using. Put it in red, because this is important. We reject. The null hypothesis. And conclude the data or, this is the other one that's important, statistically significant. So for every single question in every hypothesis that we've ever done, that standard answer is the one that you pick when the answer is yes. Right? So it doesn't matter if it's a 2 proportion, a 2 mean, a 1 mean, a single proportion, you name it. That's the phrase that you use when it's yes. Now, they then have an interpret, right? So this one, I think it's called conclude the test. And then F is called interpret the results. And the guy that we're going to pick for this one is reject the null hypothesis comma, there is sufficient evidence that, and then the bit depends on the story. So in our case, sufficient evidence that population 1 is greater than population 2. So I'm going to say, what was it? Company 1 greater than company 2. Whatever the null hypothesis, the alternate says. Are we okay with that process? Now, the good news is, I think it's good news anyway, is that every other question we're about to do today is pretty much going to be the same one. There's going to be a different story attached to it, but you're pretty much going to do the same thing each time. So I'm going to go and use...
Professor?
Yes.
So does something change for some of the later ones in the sense of maybe a hypothesized difference or something? Because I was doing the problems and I could get the t statistic right, but I kept getting the p-value wrong.
The p-value wrong gets doubled if it's a two-tailed test, if it's not equal to. So that might be the ones that we're counting wrong.
Oh, I thought the salt thing doubles it for you, but maybe not.
It should. It did the last time I looked.
Yeah. I'll double it and see what happens.
Okay. Well, we're going to do one. Maybe I'll tell you what, I'm going to pick a not equal to right away, right? We'll check it. Okay. So that way I'll find out if salt is behaving. It'd be really annoying if in some questions it doubled it for you and then the next question it decided not to, because that wouldn't be fair, because how do you know that it's not done it, right? Because all you see is an answer. So I suspect strongly that it does double them. So let's go and find a story where we're trying to prove it's not equal to. Where is your mum? She should be around, young lady. Nobody's sure who I'm talking about. I'm Sam.
Talking to me?
Yes, I am. Where's your mum?
I'm actually in her office right now, but I don't know where she is, but this is her computer. That's why the name is different.
Okay. I'm going to try and think an insult here. We need a joke. So it's coming to me. Oh, God, which one shall I tell you? This joke might be close to being offensive. I'm not sure if I can tell it. Are you okay? Does anybody feel that they might not want to hear it? I'm giving you a kind of, it's right on the border of suitable. Are you good? Are you sure? Right. This is a Scottish joke. And so you know Scottish jokes are really bad. Cruel. Right? You're getting warned. It's cruel. So this guy is drinking in a bar with his pal, and the conversation gets round to their wives, and first guy says, how you and your wife doing? He says, I hate the woman. I killed her last night. So what do you mean you killed her? He says, I killed her. The guy says, I don't believe you. He says, I killed her. I get fed up. She was nagging me. I shot her. She's dead. Buried her in the back garden. And his friend says, I don't believe you. He says, come on then, I'll take you. I'll show you. So he takes him to a house and he goes round the back garden, and sure enough, they'd dug a hole and his wife was in it, except her bum was sticking out. And the guy looked at him and says, what did you do that for? And he said, well, I needed somewhere to park my bike.
Wow. Got it.
Bad. I did give you a health warning in that one, didn't we? Okay. I'm getting a 2 thumbs. I don't think I've ever had a 2 thumbs up off you, Ripken. You liked that joke? Oh God, I'm getting a hole.
That was a good one.
It took us to week 9 to find out where your lot's sense of humor is. Okay.
Yeah, very dark and morbid. Yes.
Yeah, you get on well in Scotland then. Okay, I've forgotten what the heck I was doing. While I'm getting ready, will you lot now say hi so that I can get attendance? That way, if I forget later on, it's done. So if you can say hi, that would be great. I was trying to find a not equals to question before I distracted you and everyone else. Okay, let's see. I'll move over, go here, and we're looking for a not equals to, so that's a p-value, I don't want them. We're in the second half. Okay, that's still p's. There we are, that's the second half. Oh, there we go. Question 11 has a test to claim that the population means are different, right? So we're going to use SALT. I'll take a quick list of the numbers here. It's going to be what, a mean of 14, standard deviation of 5 with 49 people in that sample. The other sample had 64 in it. The mean was 17. The standard deviation was 6. And I'll hit SALT. Go. And let's get those numbers again. 49, 14, and 5. And the second was 64, 17, and 6. Okay. So make sure it's a 2 sample T. The first group had 49 in it. Standard deviation was, I got this wrong. The mean was 14. The sample size was 49. And the standard deviation was 5, right? That's them are now in the right place. In the second group, there was 64 in the sample. The mean was 17. And the standard deviation was 6. Right, so all of that I got straight out of the story, right? So now I'm going to go hypothesis test, and it's a not equal to, and generate the results. And the results are a difference of -3, okay, a t statistics, of roughly -2.897 and a p-value of 0.004 and lots of fives. Okay. And now I should be able to go here, compute that guy. The answer was -3. The test statistic was the t-score, so that's -2.897. And they don't give me a p-value to put a box into. What I have to do is I have to find what interval 0.0045 is in. So 0.0045 is in that interval there. Okay, let's put that on a solution and see. Put on a key. Let's see if we get that in question 11. -3, 2.897, and the right p-value. It looks like it's doubling it. I can't guarantee it because it's one of those interval things, but it looks good. And of course, there's the two sentences that you get when it's a yes. Do you see it's the same two that I wrote down? That one there and that one there, right? Don't know if that helps, Joshua. I can't really tell what you didn't get.
I got 11 actually right. It was 12 I was struggling with. It's very possible I just entered a value wrong. I don't know. So
Was it in was it in this group? Was it in this section? Okay. Well, I've got a couple of minutes at the end. We could maybe just go over that, one on one.
Thank you.
Right. Okay, so might as well start with our next question. Are you looking at question 12 right now? I'm not quite sure where I am in this big scheme of things. We on 12? Let me just check nobody's turned up late. Okay, we're good. So I'm just going to look at this fella and go through the process. It's got a lot of reading, so I'll try and keep track of it all. A Michigan study concerning preference for outdoor activities used a questionnaire with a 6-point Likert response in which 1 designated it wasn't important up to 6 extremely. They normally do a 5 scale around the 6. So, a 1 side absolutely hate it, so, don't care either way, like it, really like it. That kind of 5 seems to be natural, but they've got their own scale and that's fine. So the information that I want was N1 was 50. So they asked 50 adults about fishing. And the mean response that they got about fishing was a 4.9. Another random sample of almost the same number, 51, were asked about camping. And this group, the answer was 5.5. And in this question here, sigma 1 is 1.6 and sigma 2 is 1.3. The fact that they're telling me sigma is a bit of a pain, but I can live with that. Okay, let's go in. I think you're going to find these might be a little bit different because of the sigma, but we'll see. Oh, they're not, that's why they did it. Do you notice question 12 does not have salt in it? The salt button? Yeah, the little buggers. Neither does 13. Okay, how am I going to do this? Well, I'm going to have to show you. It would have been nice if that had had a salt button that I could have used, but we're being asked to prove here that there's a difference, right? So we're asked to prove that it's not equal to. So I'm going to show you That 20-minute question, I didn't want to, but I think I'm kind of forced to by circumstance. So I'll try and make it less than 20 minutes. All the data we need is here. The null hypothesis is that they're equal, as it always is. The alternate hypothesis is that it's not equal. And that's, you wouldn't need SOAP to do that anyway. X1 bar take away X2 bar is 4.9 take away 5.5, and that ends up being negative 0.6. I mean, SALT would have done that for you, but it's not that hard to do. Now, your test's statistic. It's normally a t-score. And if it was a t-score, you would have had a SALT button and it would have done it for you. But when sigma is known, and it is here, it is going to be a z-score. And the formula for getting it is that ugly formula. And it is because I'm telling you it is, right? So it's just what it is. In this case, negative 0.6 over that guy squared divided by 50. That's the space. Add that guy squared divided by 51. So I'll now borrow my calculator, see what we get here. I'll worry about the negative later. 0.6 divided by a square root, 1.6 squared divided by 50 plus 1.3 squared divided by 51. And the answer I get is 2.066 roughly. To 2 decimal places, 2.07. So far, so good. Right. Can anybody remember how to get a p-value? It's the probability of what happening. In this case, it's going to use 2.07. What goes there? When it's positive, what goes there?
Would it be less than? Greater than. Oh.
Greater than. And that's going to be a normal CDF. And when it's a greater than, you go 2.07, comma 9, comma 1, comma 0. And so second distribution, choice number 2, 2.07, comma 9, comma 1, comma 0. And what did I do wrong there?
Professor?
Yes.
You probably said something about this and I probably just missed it because I was trying to write the whole big formula down. But why does the negative disappear?
Oh, darn it. I said I'd forget about it for a minute and then I forgot it totally.
That's a very different number.
It's now negative, this number, right? So now it's going to be what you were wanting the first time, Ethan, but it's negative that. I think that might have explained one of the other problems I just found of not getting an answer from my calculator. So normal, when it's a negative, don't you go negative 9, negative 2.07, 0, and 1. Okay, so -9, comma, -2.07, comma 1, comma 0. There is nothing wrong with that. Okay, let me try something here. Oh, darn it in space. Does anybody know what I did wrong here? Because I now know what I did wrong here. Last chance. What did I do wrong?
Are they supposed to be switched?
Yeah, darn it in space. Okay, third time lucky, fourth time, whatever number I'm now up to. Second distribution, choice number 2, -9, comma, -2.07, comma, 1, comma 0.
Why is the 1 before the 0?
It's a 0 before 1. Can somebody else do this darn thing for me? I'm getting really annoyed at my ability to not type numbers in.
It's 0.01922 and some more numbers.
There it is. I changed it, and for some reason I'm typing the back to front. I'm getting old. -0. Well, not -0. After all that hassle, that was the p-value. Right, the test is this p-value less than alpha? Is 0.019 less than 0.05? And the answer is yes. So you'll be able to do it statistically significant out of that.